Oh, that sucks.
Yeah. Yeah.
Yeah, I've had that one too many adjustments and something breaks, and then you're back to the drawing board again.
Right.
Yeah, I had that last week. I was soldering stuff together, and it had to stack as it was soldering, so I can make the shape. And sure enough, man, it's one bad mistake. Trying to fix the solder so it didn't look all crazy, ruined the whole thing. I had to start over.
Yeah. So what are you guys going on over there, Flint?
I was gonna. Cody was trying to ask a question that you probably would be the best to answer since you're a radio guy, Tim. Uh, Asked, can your guest address the connection to the ionosphere acting like an antenna? To me, I thought it was more of a reflector.
Yes, it does act like a reflector, and then you got different layers up there. If you Google it, if tell him to Google it, or go to AWRL, and go to their website. They've got propagation maps there and charts to look at that will tell them everything. Certain frequencies, um, like I mean, if you're like for radio is HF. Um, in the evenings, generally the evenings are good. So you've got less noise, less electronic noise, and less disturbance from the sun um, for static crashes. But yeah, you can. That's why when you listen to short wave frequencies, some of them just kind of roll in as a wave and then they leave, and that's the right conditions up in the atmosphere. That's acting like a reflector, and then you're receiving it. You know what I mean? So
Hmm.
conditions.
And I had another thing I wanted to add in. Let me get to his name again. I couldn't find the video. I think he took it down or went unlisted with it, but his name is Alex Manzaro. It's this guy right here. He has the lens-free coil, but what he had set up is he had a high voltage source. It was like it's probably like basically like a Tesla coil. It was probably 20 kV, and he was sending that into a small one-to-one transformer, and then he was sending that. I believe it was rectified. He had the high voltage transformer in oil, like mineral oil, and then he was sending that to a DC motor, and then with that the motor would spin, and he was saying in the video, he was like, it's not supposed to spin at 20 kV, but it does. And no matter what he did to the other end of that shaft, it did not reflect back to the source. So it was a great video demonstration. It reminds me of the Tesla coil experiment y'all were talking about, where you're getting an isolation effect, except he was manipulating it to get rotational power out of a little DC motor. And I don't know how much, if he went further with it, because it's not on his YouTube anymore, but it was very interesting. I wished I could find that video because I wanted to try that experiment that he had going on.
If you go to John Hutchison's YouTube, um, I've tried it and I know it works. But he's got one video where I don't know what his elevation was or what he was doing. I don't think there was any details on the description of that video, but he shows speaker wire being hung up in a pine tree, and he's got a good ground, and he's taken just a permanent magnet motor. It might have been a 24 volt low current, maybe a 4-pole motor. I'm not sure, but it was a permanent magnet motor that was, probably, I don't know, 4 or 5 inches in diameter, and maybe a half a foot long, or maybe even a foot long. And every time he touched, he had one lead going to ground, and the other lead went to the antenna. And every time he touched that antenna on the short lead that stuck out of the motor started to turn, and that's just collecting some of the ionic energy around him and putting it to work.
Nice.
Imagine that. This is I said. Oh, I've said it. I know definitely one time with Flint. It's like my dream is to have a nice house in my garage or my lab, and my backyard is an AM broadcast antenna that's 1,000 feet long, sitting on an insulator and has all the guide cables with all the insulation, and
You can
because
collect.
I've done work at a AM broadcast station um, with their transmats for to load up the tower, and I'll tell you what, you can get killed by what's coming off that tower very easily to ground. There is a lot of power that can come from an antenna. And then you've got this place in Texas. I forget what town it's in. I think it's up north of Dallas, maybe, or somewhere in that area, or maybe a little more towards the north northeasterly direction from the center of Texas. There is a big fiberglass tower with a big capacity hat on the top, and that's a giant Tesla coil that they're doing a spark gap, and they're tapping that. Yep.
Huh.
And
Yeah,
Well,
that was
producing 12,000 watts of continuous energy. And I haven't checked on it for a while. I'm sure they were talking about coming up with maybe 100,000 watts. They were talking about building something else. They won't. I know a few people on YouTube. I think they passed away from COVID, but I know two people that went there and got chased away by security.
hmm.
Hmm.
So were they even running any driving system, or just pulling the energy out of the ionosphere?
No, they were tapping the energy and putting it into a load bank and making measurements. Yeah, real power,
Nice.
measuring real power. Hmm.
Yeah,
Yeah,
Yeah.
same as
because
if you did a balloon, right? If you floated a mylar balloon with a conductive wire, it's going to eventually start shocking the shit out of you if you're
Oh
being
yeah,
honest.
yeah, yeah.
Yeah.
And just think, remember NASA did an experiment. I forget what mission it was with the space shuttle, but they had what was this wire, 3 miles long or 4 miles long, or I don't know what all the details were, but there was a lot. It was a big antenna, and that thing disintegrated in just one big flash.
oh wow,
So that was connected to the shuttle, and they let it out, and before you know it, the thing just disintegrated. It just came in contact with so much power that cable was like a filament, like a light bulb, and just got overloaded and just blown apart. Yeah.
man, that's so cool. Because it reminds me of Tesla's radiant energy patent, and then his Tesla tower. It probably pulled all the energy from the ionosphere.
Yeah, well, he's on the Earth. Tesla was on the Earth doing the same thing that the shuttle was doing in space. But you have to ask yourself, if if you want to collect energy, if it's that easy, is it that easy to collect energy? Just just send this antenna out from the back of your spacecraft and have that power your engines.
Oh yeah,
You know, whether they be plasma or whatever kind of propulsion that's going to be. That's your power source. If you think about it. And who knows? Some of these aircraft, the metallic value of these UFOs that come down, um, that's they've found a way of tapping that. Um, I don't know if that's that. I mean, that could be the ether. I mean, really, nobody knows what dark matter is. Nobody knows what this energy field is. Nobody seems to really have put their finger on it. But we know that there's these anomalies out there in space that can't happen here on the ground. So
well, Otis T. Carr said
potential
that.
power.
Yeah, Otis T. Carr said that his OTCX1 would be over Unity when it reached the ionosphere, and he was saying the same thing, that he pulled the energy from it and it was able to
Mm,
drive the craft.
unbelievable. Yeah. So it's out there. It's around you. It's when you're walking down the sidewalk, you've got this. It's like the bird on the high tension line. He doesn't know he's sitting on 275,000 volts. It's just where he wants to eat his seeds and shit. You know, he doesn't know.
Yeah, it doesn't care either.
Yeah, totally clueless. Yeah.
It'd be cool if you could make a drone that could go up, say 500 feet, and it could collect the ionosphere and run itself off of it. But you'd have to have a ground, or I don't know if you can make a virtual ground somehow. But I guess
Well,
you
why
could.
not? Why not make it two pole?
Oh yeah,
Why not have two poles coming out or two wires going out?
yeah.
Because
Well, I
now
guess yeah. If you had one up high and one droop down, and you
hmm
had like a conductive something on it, like a ball,
right.
say a sphere, and your difference was enough, I guess you could potentially run that drone indefinitely, just with propellers. Just
Well,
sitting.
I mean, put it this way: just the capacitance value of the space shuttle, whatever that whole surface was of the shuttle, that's still a capacity hat. The cable that you're letting out behind you, that's your antenna. So it's like a Tesla coil. You got a capacity hat at the top. You take that capacity hat off. You're changing the frequency of the coil.
Hmm.
So the size of the hat on top of the coil is there's a value to it. So you can use that as your floating common because you're out in the middle of this. It's everywhere. So you've got both ends. You got both ends of the circuit. I mean, I bet you could probably trail four wires behind the spacecraft and do some that are only going out 100 feet or a couple of 100 feet, and then do the others that are going further away. And then there's no way of them arcing. I guarantee you, the energy pickup is beyond belief. But I think they could do something like that. I don't know why we spend all this time in the space shuttle playing with plants. I mean, it's all important, but they should be pursuing that. And it bothers me why they were puzzled how the thing just disintegrated because it got overloaded with power and it wasn't pursued. They didn't pursue it again, and I want to know. I'm just like always wondered why. Why? What are they hiding? Because that would be incredible news. The space station wouldn't need solar panels on it. What do you need solar panels for? Just tether a cable out. You know, make your spacecraft one your common ground, and that antenna is uh, is your radiator to pick it up.
Yeah, well, they don't want to tell you that because they want you to
No,
believe it's all solar panels.
no, but I guarantee you, there's something there.
Oh
You
yeah.
know, it only makes sense because it works here. We can produce it here. You got a bunch of Tesla coils behind you that you can do the same thing, just not in space.
Oh
Yeah.
yeah. Well, you can drive a rod into the ground and put one of these Tesla coils over it and pull energy right out of the earth. You
hmm
could put an antenna to one of these and pull it right out of the sky too. They
Yeah.
actually put a limit on the height that you can drive your drone in the air because people are taking it out, putting balloons out there, doing Corona motors out of it, stuff like that, and they're learning that it's actually working. And when you start coupling that with the ground and put it into a capacitor, and you can adjust the capacity of it, because you're getting more amps from the ground, more voltage from the sky, it'll blend into a beautiful, array of energy out of it. So yeah, it's really interesting that it's all free, and we even have the height of towers and everything to pull the energy right out of it. And
Oh my God. Yeah. Yeah. Um,
it, it said that the St. Louis
I was
Arch.
on a tower. I don't have to cut you on, Nathan. I was on a
uh,
tower time when I was younger. We were building the 400-foot tower, and so I'm riding a side arm. I'm riding a cable that's connected to a shiv that's on the side arm that's going up the side of the tower, pulling up another section of the tower so we can stack it. And that side arm is hanging off of straps. And I've gotten in between when I was switching off from the side arm, the gin pole. That's really a gin pole. Switching from the gin pole to the tower, transferring over, and the gin pole is just hanging on the tower on straps, and it's just floating. And I got jolted. I was lashed off, and it's a good thing because I got jolted just having leaving the gin pole and then letting that go. And when I let go and I got far enough away that the arc jumped from me, went through me into the tower. And the
Ooh.
tower was grounded as we were building, as we were stacking tower sections. But I got jolted just off a 20-foot section up, like, I don't know, I think we were like 300 feet or so stacking tower. And and I got jolted just by that 120-foot surface area. That and it was I forget what the Roan number was on it. It was a Roan tower, but I think it was a 4-foot face, triangular, 4 foot, and I got jolted pretty good. So the
Oh,
higher you go, the higher the potential.
oh yeah.
Mhm.
Yeah.
Yeah, I was going to say earlier the St. Louis Arch, I said once they put that thing up, the weather changed. They were having a lot of weather problems. They put that thing up, and all of a sudden the weather in the area changed.
Hmm.
So they stopped getting too many thunderstorms through there. They stopped getting, anomalies up in there. Completely changed it. So there's something to that because it just grounds out to the from the ionosphere into the ground at that point. It's like a short. You know what I mean? It kills the energy in the air, so it can't build up too high, so it cannot create the weather anomalies.
Right.
It'd be interesting to see what the FCC would say, Tim, if you called them and said, "Hey, I want to put up a 400-foot radio tower, or 1,000, whatever, and I just because I want it." I wonder what they would say to you. Like, "Oh, I bet they'd tell you can't do it legally." They'd have something to say.
Oh
Yeah, I'm
yeah,
sure somebody will have a problem with it. You know.
get a visit from the black suit guy.
Yeah.
That's what you're gonna get.
Probably.
Yeah. But I mean, to have imagine having possession of an AM broadcast tower. Um, that would be
Hmm.
pretty crazy to get access to something like that. In other words, that's not being used as an AM station anymore, and it's just deserted. And to have the right to go in there and experiment to see how much power you could really tap off that thing that'd be nice.
I bet it would be
That's
a
like a
lot.
bucket. That's a bucket list thing right there. You know.
Wonder if you can find a property with an old radio station that was shut down like a long time ago that has a huge tower on it. Then you'd be set.
Oh my God, yeah, that'd be great. Yeah, yeah,
You wouldn't have to worry about the permit or nothing. It's already there, and you just tell them I don't
yeah,
know what you're talking about.
yeah. And you'd be off grid too, because you won't be needing anything from the power company. That's for sure.
No, you won't.
Nope.
Just get your conversions right.
Yeah. I had my property in Plymouth. Um, I had 40 feet of PVC in the year. I was doing a drilling. I had a drilling company, so I augured a hole and I had 6-inch PVC, 40 feet of that in the ground, and I just kept on telescoping. And I had it so at the base this winch would wind up the cable, and this telescopic PVC tower would come out of the ground, and they had all stops at different points, so I could touch 60 feet, but it was I would never have kept it. I always had it like right around 45, 50 feet. But I had 20 feet of plastic coated chicken wire hanging from the top down, and then I had a ground connection. And just with that plastic coated wire caught, um, brought all the way down, and then doing a spot gap into the Tesla coiler was, I don't know, maybe about this tall. It was a small one, maybe a 10-inch or 11-inch. But I used a spark plug with a drilled and tapped into an aluminum plate, and that was my heat sink. And that was my spark gap going into the high voltage side of the Tesla coil. And that primary produced enough power to light a 20-watt LED light. It was like one of the first LED lights to come out at the Home Depot, and it ran that for 5 years straight. Never messed with it. Yeah.
Just
So
40
that's
feet.
just 40 feet in the air, 20 feet of plastic coated chicken wire with a good connection to it, hanging on rope, was all I needed. And that lit up the backyard. I had a little over an acre of property there, so like the backyard was lit up at nighttime every night from that 120-watt light LED. Yeah,
Nice. That's so
yeah,
cool.
24/7.
Gotta love free power. Anywhere you can get it.
Yeah.
Tim, will you check the private chat real quick? Because I didn't want to say it out loud unless you just click where the comments are. Because it sounded like you started to maybe go into that a minute ago, but I didn't know if you wanted to talk about that.
So who are we talking about? Yanni or John?
No. Go to our private chat. Click
Oh,
private chat. Because I don't remember if you did that.
yeah, we did.
Oh, okay.
Yeah, we did. Yeah. Why, you want to talk about it?
Well, I couldn't remember if it was last time. Yeah, if you want to, because that
Oh,
was a
hey,
really interesting.
it's Nathan's show. You know.
Yeah.
What is, I'm lost. I don't even know what you guys are going into.
The OG free. Yeah.
The first he wants to know if we talked. Did I talk about the first gen, free gen?
Maybe you did after I
My
left.
last live, or I think it was on Faraday's channel. Or did we talk
Maybe.
about it on our?
I'll tell you what, feel free to talk about it. So, because I'm lost on what you guys are going with, so just go for it.
I'm trying to remember what live it was for when there's on Faraday's channel, or the live that me and Flint did.
I don't remember. But
That don't matter.
yeah, go into let's see. Describe how it was running that camper, or I guess a little what you're willing to go into on that machine, because you had a lot of parts. You had Raytheon parts in it. Because I got some. I bought some of that. Yeah.
The machine had an 80-pound flywheel on it. It had 2 ECMs. It had a Samsung for a prime mover. And as far as the prime mover is concerned, I had brought out the neutral connections. So the Samsung was running like a Bedini circuit on 2 phases. And through, if you think of, geez, I don't know if I should share that. Holy shit!
You can be. There's a way you can be broad.
Wait a minute. I gotta figure out a better way. I can't. That's a.
I mean, that's why I was trying to ask you privately, Tim.
That's a big one, boys. I don't know if I can do this.
Yeah, I'd poke the bear.
All right, so we'll keep the description. We'll keep the description as a simulated cap bank. In a very crude form. That's what was controlling the prime mover. And the machine surged about it surged between anywhere between 150 to like 200 and excuse me, my legs cramping up. Maybe close to 300 RPMs. So it was a surge up and down, and depending on loading and how much you were taking from the flywheel, obviously it took that much time for it to build back up. So it was a very narrow RPM range. But when the machine got up to speed, that's when it would go in a mode of generating a spurt of about 1100 watts of energy. When it slowed down, collection stopped, and it started on its next build up, building back into the flywheel, and gaining its RPM back up to where it should be, and then the cycle would start over. Another spurt of energy would come out and charge into what I had was 6 8D batteries. That was my 48-volt battery system, and that ran my it
Uh,
that charged 24/7. The only consumable thing out of the whole time I used it was the belt, the 1 inch timing belt that I had on there. No issues with the bearings. The thing just, that was, the timing belt was the only consumable out of the whole thing. Other than that, it just ran, and it charged a 48-volt battery bank, which ran a pure sine 48-volt inverter, and it not only supplied power for my RV, but it supplied power for my friends' RVs when they were up there. So my unit, see, from where the camp was, the closest telephone pole or the closest power pole was like 60 miles away. And it stayed like that for a long time while I owned the property over the years until finally it got closer. And the guy that I sold it to, he finally got power and this is like almost 20 years later. It's to a point where more people moved in, it was worth it for them to move power further into the woods. But these are logging roads were used for get to properties. So there was no incentive to run power down a logging road. So it took time. But that ran other RVs. That supplied power for other RVs, not just mine. My friends said everybody parked one up there. I had a big roofed in area where everybody could just back in their RVs all the way around the center point of this open walls, two-tiered roof system. So we had always had a campfire in the center, smokers and stuff, um, and everybody got power off me. Yeah.
Nice.
Everybody knew that they couldn't tell anybody. If any friends came over, they'd be like, "Where's the power coming from?" It's, "Oh yeah, the biggest story was we got a generator running out back. Don't worry about it." And that's the way it was always dealt with, and nobody never questioned it. But a few people were smart enough to try and it's like, "Hey, where's all this power coming from?" It's like, I know there's no telephone poles here, and it's like, yeah, we got a generator running. Well, where is it? It's like it's off. We don't want to hear it, so it's far away. Yeah. So that was the bullshit story that we gave everybody, and so there was, 8 of my friends that kept it quiet. They didn't want to ruin a good thing. They could go up and not worry about having a source of power and not worry about dealing with a generator. So everybody kept an eye on it when I wasn't there. Yeah. But it
yeah,
ran.
and
It ran for
yeah,
2 years straight. Yeah.
Wow. Now I really wish you had the specifics you could tell us on it, because some of the runs like that with free energy, everybody wants it.
I worked on that for a long time and, gave it up and then came back to it and looked at things in a different light and then tried something else. And so it was all trial and error. Um, But yeah, there is. It's actually to loop a machine is what has to happen. It's simple, stupid. It's so stupid that it's like really literally out in the open. All you got to do is just you got to just you're capitalizing on every known thing that you can do, but there are some things that need to be treated a certain way, and then once you do that, it opens up a big opportunity to capitalize on and still maintain its own speed, keep itself going. Yeah.
Yeah.
Can
How
you go
many
in
hours do you
depth a
think
little
it
more? Sorry.
Hmm.
Oh, sorry.
What,
I think we
Nathan?
both talked at the same time. What was you asking, Nathan?
Oh, I just wanted to go in depth a little bit more on some of the things you needed to know for that loop.
I bet you do.
Yeah,
Hey,
listen,
I'm
baby.
trying. You
How
can't
many
blame me for
hours?
that.
Hey, Flynn, I think this guy thinks he's Joe Rogan or something. I don't know what's going
Yeah,
on.
yeah. Well, how many hours do you think you actually had in that first generation before you got it to run? To put it in perspective,
Um,
why this is
from the
kind
time
of
I got it looped, let's see, when I first got it looped, I think I only had a 20-pound flywheel on there. It was a good flywheel. It was off a small little steam engine. Um, and the ultimately the flywheel I had a friend that had a really big lathe, so it was originally a barbell weight that was quarter inches thick, and I think it was like 19 or 22 inches in diameter, 19 inches. I think it was 19 inches in diameter. Um, and so he chucked the thing in and turned down, left all the mass on the outside edge, and thinned it out from the center out. Um, Still structurally good enough to support on the shaft, but and then he milled out a lot of areas. So it was a typical flywheel, and I would say probably 80% of its mass was on the outside edge of the flywheel,
Mm.
and it acted nice. It really acted like a great flywheel. Yeah, but that's the key to the whole thing. You're what you're spending in the cost to speed up the flywheel, and then when your loading takes place, um, when you're filling the cap up or your condenser bank, That's an easier load than um, trying to run an inductive or a resistive load. So your energy is being stored, you're stealing time, and then you're giving it back. But in the process of stealing time, you're capitalizing on the momentum of the flywheel to a certain point from the higher RPM to the lower RPM. That duration time is the free lunch pretty much, and then after that you have to let it go and let the system build back up again, and then you tap it on the down cycle when it's spinning down. It's because of the load. So if the battery bank is up to volts and it's at its nominal voltage rating, then there's not a big demand anymore. The inverter would be running off the battery bank, which was flooded lead acid batteries, and the cost to do that. So your duration time changed. It was quicker when you weren't putting a demand on the system. That surge was up and down like literally like this, maybe 50, 40, 50 RPMs. And then when you started using power, that's when it went all the way down to about 200, 250 RPMs, and then there was a cutoff, which I could adjust it. And it's basically I had it labeled as stall level, because if you went too low with it, the system would stall and shut off. It would just kill itself. So also the ECM, the ECM has a natural characteristic about it. When you get up to when the ECM is used as a motor, there's a resonant RPM that they're rated at. Like majority of them are like 1,050 RPMs. Excuse me, like 1,050. So if you run that ECM at 1,150 or 200 or 250 RPMs, you're going to get the same output out of that ECM when it's being used as a permanent magnet alternator. But it's the cost to do it is easier. There's less torque. So I call it the breakaway effect because you're breaking away from spending more energy to turn that at a higher RPM, and you're getting the same output. You're getting the same output that you were getting at a resonant RPM, but when you turn it faster, it gets easier at the same load. And that was one of the other effects that how the first gen works, um, which is a huge effect that you're capitalizing on. So you need the flywheel to capitalize on that, to stay within that breakaway range, so that you can get as much power as you can out of it before you get to stall level. And then there's a disconnect, where you're not taking any more power out of the system. It naturally wants to build itself up. And the only reason why it's trying to build up is because of the advantages that are taking place, with the leverage from the Samsung, from the center of the shaft out 11 inches. Um, so all these different things that you're capitalizing on allows the system to build up an RPM to a certain level. And then you're going to put a load on it again and bring it down close to stall RPM. And then you're going to get out of it, shut it off. You're not shutting the unit off, but you're going to do a disconnect where you're not taking any more from the system until it builds back up. So it's all done with different circuits to control all that. And I had it down to where it was just one potentiometer, or I was using that to control like a governor, in essence, but more like, the lower limit, bringing down the stall RPM, bringing down the system to where it's just gonna jump out and disconnect at the right moment where before you stall it is the key. And you can set that higher. And if you set that level higher, then you're taking less out of the system for every spurt in RPM when it goes up and down. So it's a cycle. And in that cycle, you're just capitalizing for a moment, taking what you can out of it without killing it, and then it starts over again. So every 2.5 to 3 seconds, it's a give and take. It's giving to the battery bank, and then the battery bank's disconnected from the unit until it reaches its maximum RPM, and then it knows, okay, relay's triggered. We're going to close a contactor. Now we're going to start taking power and sending that through a bridge into the battery bank and start charging again. And I had accrued, the limit on that was basically, I was disabling the mag contactor before the AC connection going to the DC bridge, when the battery bank at a certain voltage level. I had that used in a voltage regulator to adjust that for, controlling it. So I can control in a very crude way that worked flawlessly, but in a simple form, just a cutout relay when the battery voltage was like at 51, 52 volts, is when the free gen wasn't charging the battery bank anymore. It was like literally disconnected from it. So it ran in this idle mode where it wasn't doing anything, and it stayed. It's an unloaded situation, maybe 30 or 40 RPM change. It's just hovering at the top, and it's only slowing down a little and then speeding up because there's no demand, there's no fight, there's nothing difficult to keep it going, there's nothing stopping it because you're not drawing power from it. Yeah. So you're drawing power from the system, and you're adjusting that threshold to disconnect until it recovers and starts over. So it's not a continuous thing, but this cycle will go over and over and over 24/7. So
Yeah.
it's like taking your solar panels and pointing towards the sun and then putting them down towards the ground. 3 seconds later, you're pointing it back towards the sun again. Then you're pointing it back towards the ground. As a comparison.
You're only taking out of it the excess energy, not the energy that would stall the system. That's why.
Yeah, I mean, you can take it all out, and then there's nothing left for it to recover and build back. So the stall RPM adjustment is you're adjusting that threshold um, just before you kill the machine. So you're preventing that. So it's a limit on how much you can look at it as a threshold to keep it from killing itself, or you can look at it as your charge rate, which you can only get so much. So it's a small window, but it's a big spurt, and it's just continuous over and over and over.
Yeah, and I think I was the one that estimated it that first generation was approximately about 500 watts RMS. Does that sound right, Tim?
Yeah.
If you balanced it between its up and down cycle, because you were drawing a lot of load off of it, you were able to run your heat pumps that you converted, your RV stuff.
Yes. Yeah. It performed nicely. An easy 1,000 watts all day long, every day. You could push it to like 1,100 and almost just a little bit past 1,200 watts was a stall point. So I always had it adjusted because of worrying about being real cold up in Maine and tighter bearings. Because the machine didn't get warm. It never got warm. So it was always cold in the cellar because this was in the cellar of the fifth wheel. So I factored in cold temperatures, and so I wasn't trying to be greedy with it. My thought was, it's like every 2.5, 3 seconds, I can get a spurt of 1,000 watts. I mean, what else? What do you need? There's nothing else you need. Yeah. So you got all those spurts add up. You the reverse, and then my AC units, I had converted them to reverse AC, so they were acting like heat pumps. So it was my AC in the summer and my heat in the wintertime. And that was I didn't have to worry about changing propane bottles or even bringing any of that stuff other than using it for cooking because of the gas stove. There was no need of that. Yeah. So it was.
It almost sounds like your flywheel was acting like a flywheel battery. It would get a lot of free spin, and you'd collect all the energy, and then you'd go back to work. And then
yes. So in that buildup of storing all that energy in the flywheel and building up and increasing the RPM, that was the energy I was grabbing. The gyroscopics, the stored energy in the flywheel was what I was using to convert that energy into electricity through the ECM being used as a permanent magnet motor. And if it's running in its breakaway RPM, where the cost, you're still getting the same output, but at a higher RPM, so it's less torque to turn that generator. So the RPM drop is slower than it would be if it was a conventional type system, conventional motor with a conventional generator with a flywheel on it, where it was, it wasn't in its sweet spot. It would just slow right down, and that would be the end of it. Yeah. So.
So I'd like to show one of my videos. It's the one with the dual ECM surge on my channel. I had it private. I don't remember setting it to private, but I did. Do I just open that file when I click present, Nathan?
Yeah, present. It'll pop up on my screen. I'll put it on for you.
Okay, so real quick before we show it, this machine was not. It had a loop on itself, but it wasn't optimized. It was still drawing around 266 watts. But what you get to see is if you watch the meter, and I tried multiple meters, you'll see it look linear at first, and then in the moment you'll even hear a noise change in the machine. Once that noise changes, you'll see the wattage rises slightly, but on that meter you'll see a slosh effect where it'll slosh all the way up to almost 900 watt surge. I'll go ahead and send it. I think that's doing it.
All right, got my hulls adjusted. Now it'll run.
Sound on it. You don't really need sound
putting
because
out
you can
about
see that.
18, but check this out.
It'll take a
ECMs
minute.
will put out,
as soon as this power
Once it
supply
gets up
goes
to a
up
certain
to
speed, so I
266,
might-
that's when you'll.
I might need
on that
to
one
go
meter.
harder 1-to-1.
So hold on real quick before we go any further. The motors that you have on there, they look like air conditioning motors.
Those are, yeah, that's what they are.
Okay.
They're ECM motors, repurposed as a generator. That's what Tim's used on his free gens the whole time. Yeah.
And not to sidetrack from things, but also I've got the other system that I've been working on for a while. That's using toroidal motor. Loves back EMF. The more back EMF involved, it just eats it like candy. It's crazy. And so a prime mover is a toroidal motor, and on each side of the clock box is going to be two 8-pole toroidal generators that are negating lensing. So that's going to be my prize build right there, because that's going to be an incredible machine.
Sounds like it.
Yeah, it's going to be, because it's really I'm taking the back EMF and let me put it this way. If I took the toroidal generator and resonated it, put all the coils in series and resonated that to its output, and spin the shaft actually aids itself. The moment you start creating back EMF, the opposite polarities and that's going on in the core and the magnet rotor is actually it's aiding itself. So it's literally, when you turn it, it tries to turn itself. It's taking the back EMF immediately as a tool like the bit would be doing, except we're using the back EMF as an addition to rotation. So you're negating the back EMF as a motor, and you're negating back EMF as a generator. So it's win-win. Using it as a generator and using it as a prime mover, the same thing takes place. So that will be a system that will be, I'll have to spend a lot of focus on controlling it, because that will truly be a runaway system immediately. Like I'm even thinking that that I'm probably going to put a pull start from a pull cord, like from a lawnmower or whatever, or for a small gas engine. I'm going to be able to put a pull cord attachment on that with the clutch, with the latch, and be able to literally start it up with maybe just one or two good quick pulls, and it will take off.
Nice.
This type of thing you could take out in the middle of nowhere, put that in your tent. It's not going to make much noise, and it's just going to be amazing. It really is. It's going to be amazing. And I need to finish it.
The lock ridge was like that. Remember, Tim?
Yes. And what's nice, what Bedini doesn't tell you about the lock ridge is the capacitor, the lock ridge generator, which was your generator on the Volkswagen, was a Bosch generator. And the early 6-volt ones were 4-pole, and so you're taking the 6-volt out, and you're putting the 12-volt armature in there, and you're moving your brushes in such a way, they need to be really thin, so they're only sitting on one bar on the commutator, but you're creating phasing. And then with the frame of the generator being machined out, so there's a notch on both sides of it. So you got a north and pole flux coming off the Bosch generator, and with your capacitors are made and wound around that same area. So you've got a magnetic flux blowing into a capacitor, creating more copper electrons, and the capacitor was made with copper foil. So the original one that was used, that they made, and this guy that was making it, so the story goes, he was soldering. The older style televisions had these copper wide, like 2.5 inch or 3 inch bands that went all the way around the transformer, the power transformer, and that was to basically trap any stray flux coming off that, because that's going to be on the chassis of the TV. They couldn't have the magnetic field come off that and affect the electron beam on the cathode ray tube, because it would distort the picture. So they ultimately, as the TV screens got bigger, they needed bigger transformers, and they had to kill the stray currents coming off of that. So he took those copper flash and strips that were basically went around the transformer and soldered to itself. He made his capacitors out of that, and used butcher paper as the insulator. I think it had to be at least more than one layer, maybe 2 or 3 layers, but that was his dielectric on the capacitor, which is kind of crazy.
Right. He never talked about that either.
Right.
Yeah.
So with your 4 brushes on the commutator, you're actually getting pulse DC. The output of this machine was a pulse DC machine, but supposedly it was good for about 300 watts or 250 watts. Yeah. And then the only reason why that system worked, and it had a little flywheel right where the pulley was, and I guess they had a notch on it. They could wrap the rope around it, and that's how they started it. It was started with a pull cord.
Yeah.
Really?
He said you couldn't pull 1 watt over, I think, 300, or it would just stall out and die.
Right. Yeah.
Something like that. Yeah. 300.
Breaking point. Yeah.
Yep.
Stall point.
Wow. All right. You want to watch the video real quick?
Sure. Yeah.
Jumped out of CC. Now we're good. Look at that production.
Starts right. If you can see it, it's pretty much linear right
Putting
now.
out
Not
300 now. Losing 2.
Yeah, now it will. Watch that meter. And I tried it on multiple meters.
Now
I
it's
tried it
surging
on multiple
up to
machines.
800
and
watts.
Once I got a condition set up,
And that's
they
using
all surged like
268.
that, just like Tim was telling everybody. Now it wasn't in a loop state because I wasn't doing the other half of
these things are
the
putting
system
out,
like
man.
Tim was.
If that thing's right,
Controlling when
it
it's
looks like it was
dumping and when it's
fluctuating a
not.
bit.
I just had a closed loop with no. Sorry, I was reading that. It was just loop back. It was like a cheap way to do some tests, because when I do tests like that, I do them really simple, and I'll do a lot of tests in like a couple of days. So it's like a lot of work, but I'll write down all the data, find out what's the most efficient, what's not, what gear ratios. If you look at those gears, I probably bought 12 different gears to try different ratios off the Samsung to those ECM driving generators. Yeah, I continue messing with it.
Sorry,
Yeah.
I turned the volume down so you could talk.
Yeah, I couldn't even hear it on my end at all.
Oh, yeah, we all heard it.
Oh, okay.
Yeah.
No, so you have a Samsung drum motor on the end, and then you have 2 converted air conditioning motors on the other side.
Yeah,
Okay.
and when you say converted, it's really not converted. They're actually great 3-phase generators right out of the box. All you got to do is spin it and collect. Yeah.
And when Tim was saying earlier he was driving the motor, was he saying that in the 3-pole system that they have on those drum motors, he only used 2 of them?
Yes, because what I was doing was I had the neutral pulled out, so I had access to that. And what I was doing was I was running two phases as a Bedini circuit, and I was getting my signal off the other phase. So my positive and my negative off that unused phase was my signal winding, and then that went through one part of the circuit to drive it for the electric switch, in which I used big transistors from an MRI unit. The capacitance value on that switch was I think like 2.5 UF, and so that actually resonated. It was like it was a marriage made in heaven because the switch actually resonated the winding of the Samsung. Um, but it was set up like a Bedini type triggering circuit, and so it took two pots. I had two potentiometers with the same value running on the same shaft, and that was my Bedini drive circuit. And what I did was, I don't know if I should talk about that. No, I'm not going to talk about that. So I drove the Bedini. Yeah, that's serious. Somebody'd have to pay me like a lot of money to get that one out of me. But what I was doing was I was driving that Samsung when I needed to. That's about as far as I'll go with that.
Yeah, that's
When I
Tim's
needed
baby.
when I needed more RPM, that's when I would drive the Bedini circuit.
Okay, hold on. So it's definitely a merry-go-round. You only tap it when you need to, and you still get everything out of it, and then you get a little bit back.
Have you ever moved an oxygen bottle across a shop floor?
I'm sorry, say it one more time.
Oh, I definitely have.
Oh, I know you have, Flint. So, I mean, are you going to carry the oxygen bottle, or are you going to tip it on its side and just kick it with your feet once in a while, and just hold your hand where the cap or the top of the bottle would be, and just stare that tank to where you want to go, and you're kicking it once in a while with your feet. So you've got the stored momentum
I'll
in
be
that
right back.
bottle, and you're letting it slide through your hand right where the screw-on cap is for the top of the bottle to get to the valve. So you're letting that slide through your hands. So it's no effort. You're just kicking the bottle with your foot. It's turning it because you're kicking the edge, and you're just steering it off to where you want. So the Samsung with the Bedini circuit is very efficient because you're only hitting that motor when you want to, when you need to, and then you take the power away, and then that's it. So that's how you're controlling it. So your Bedini drive circuit, the driver circuit for your input from your signal from your coils, getting the right pulse at the right time. Um, you can adjust your drive level. So it all depends on how hard that. My governor circuit that I had on that controls the drive level of the Bedini circuit. That was my speed control. And then how much I wanted to put into it, and those were the kicks to the tank, to the oxygen bottle. So the spurts of energy that I would put into spinning that bottle were like the kick with your foot. I think that's probably the best way of describing it. So you're not spending a lot of time. You're slapping the flywheel. You're slapping the flywheel when you need to get the RPM back up. Then you're not slapping it anymore. So you're not hitting it with your hand to speed it up.
Mhm.
Then to pull your hand away, and now you're tapping that energy that's coming down. So the amount of effort that you're putting into it is not nearly as much as what you're taking out of it through time. And as long as you have your levels adjusted just right, it will recover and you can start the cycle over. You can just start it over. Then you'll tap it again. So you're kicking it again with your foot. You're kicking that bottle, that oxygen bottle. You could go across a shop like 60 feet in no time just by kicking that bottle and letting it slide. A real good flywheel is got all its mass on the outer edge, and that's where all the gyroscopic energy is at the maximum distance out. over the center of that shaft is the key. Yeah. So
That's like the
the
magic of the whole system, isn't it? That flywheel.
You-
Without it, you don't get a whole lot.
if you took, as an experiment, I would take the flywheel off and it wouldn't do anything. I couldn't get it to do anything. It was nothing without the flywheel. It's nothing. You know, you might get it to run for just a teeny little bit, and then it's just slowly going to stop. Yeah, because you're putting everything you need to get into it to try and keep it going, and it's the wrong time because you're not at the right RPM. So the right size flywheel running at the right RPM to get that breakaway. The Samsung motor has all its coils and magnets on that outer edge. So you have leverage over the shaft. That's an advantage. It's all these little things that add up to something that's nice. A nice anomaly. I'm going to call it an anomaly. I don't know what you want to call it. Is it free? I guess so. It just keeps going if you don't disrupt it too much. So you take just enough energy out of it at every moment of peak, and not stall it, and then wait for the next cycle and start over. So and that build time is just a little bit longer than what you're getting out as a spurt as it winds down, but it's capable of building back up and start over again. It's capable of building its RPM back up, and then you just tap it again. You're taking the power out just for a little bit until the cycle starts over, and it just repeats over and over like that, up and down, up and down, up and down. But what's nice about the toroidal motor and the toroidal generator is, it's gonna love to generate. It's gonna want to see it's going to want to see the load on the shaft because it's going to assist itself. So the toroidal motor assists itself. It's the only way I can describe it. When you power it, there is a little peak, and it immediately your input current is dropping, because it tries to assist itself. So that wasted back EMF in a motor is being utilized as electromotive force at the right moment because it's a toroidal ring. Your rotor, your magnetic rotor, is going to be north south north south. So you have the right flux coming in at the right motor at the right moment, attracting your back EMF, which is the right polarity. So they're attracting each other. It's over and over and over like that. Yeah, that's as a generator. Then when you're being used, when you're using a toroidal motor as a motor, which is the generator, you're just using one as a motor and you're using one as a generator. My thought process, the way I'm looking at my new system is, the toroidal motor is 4-pole, or two-pole motors is the best way to think about it. But my generators are going to be 8-pole generators. So my frequency rate is faster than what I'm using for a 2-pole. I'm going to have an 8-pole generating current that loves back EMF, so it likes to load. And so that's going to assist in rotation and help it turn a little faster or make the job easier, like hardly any